Heard Betelgeuse is about to explode? And it hasn't yet. But recently, Betelgeuse has been acting strange again. So will it explode this time? The answer is uncertain. But what we do know is, astronomers have made new discoveries. Its brightness will slowly and irregularly dim, pulsating with variable energy. And for a star nearing its end, it's rotating too fast. So astronomers now suspect this cosmic giant might be dancing with another hidden companion. Quick recap. Betelgeuse is a massive red supergiant. How big is it? If placed at the center of our solar system, it would engulf Earth and several inner planets. Yet, despite its brilliance, something else seems to be secretly influencing its every move. This invisible, mysterious force could be a companion star, a mystery shrouded in stellar winds and cosmic dust. This mystery might even overturn our understanding of how massive stars live and die. Betelgeuse, the dazzling red star on Orion's shoulder, has fascinated astronomers for centuries. But recent decades of observation show this massive supergiant isn't just huge, it's also quite volatile. In late 2019, its brightness suddenly plummeted. It became a global sensation. This dramatic dimming led to widespread speculation. Was it about to go supernova? However, later studies showed the dimming was caused by a massive dust cloud. This dust likely formed from stellar material ejected by Betelgeuse itself. Though it didn't explode, it raised a bigger question. What exactly is happening inside or around this star? Betelgeuse's brightness has always fluctuated periodically, but one cycle stands out. A slow, repeating 2,100-day pattern. This long-period brightness change is hard to explain by internal stellar pulsations alone. Its regularity suggests an external force is at play. Perhaps another celestial body is tugging at it with gravity. Later, astronomers proposed Betelgeuse might have a low-mass companion star, orbiting Betelgeuse every 6 years. This idea quickly gained traction. So, the companion's distance from Betelgeuse would be similar to Saturn's orbit around the Sun. To investigate, Jared Goldberg's team used the Hubble Space Telescope's STEES spectrograph, targeting far ultraviolet wavelengths, hoping to find that potentially high-temperature but dim companion star. Observation times were carefully chosen, targeting the most favorable position on the suspected companion's orbit. Unfortunately, no companion star was clearly found. Betelgeuse itself is too bright and surrounded by too much dust, making the search incredibly difficult. However, while not directly detected, this doesn't negate the indirect evidence. Many scientists believe the companion star is simply too dim or obscured by Betelgeuse's glare, invisible to current instruments. Hubble's observations, far from settling the matter, only deepen the mystery. Brightness fluctuations, spectral pattern changes, and unexpected surface activity. All signs suggest something or another star is gravitationally interacting with this aging giant. Betelgeuse having a hidden companion isn't just an intriguing idea, could be the key to unlocking Betelgeuse's decades of anomalous behavior. Betelgeuse's most surprising aspect is its rapid rotation. Its rotation speed is roughly 5 to 15 kilometers per second. For a red supergiant in its twilight years, this is much faster than theoretical models predict. If it were alone, it would have slowed down. But if a smaller star is close enough, could use tidal forces to keep Betelgeuse rotating rapidly, similar to how the moon affects Earth's tides. Then there's that 2,100-day long period. Brightness change. It's not random. It's precisely regular. If a nearby celestial body is tugging at Betelgeuse's outer atmosphere, it could explain why its outer layers expand and contract in ways internal dynamics can't. This theory also aligns with the general trends of stellar evolution. Most massive stars form in binary or multi-star systems. So if Betelgeuse were truly alone, that would be unusual. Some scientists propose Betelgeuse's peculiar behavior might be because it long ago swallowed a smaller companion star. A stellar merger occurred. This could explain some of its rotation and mass. However, It doesn't explain the rhythmic brightness and motion changes we still observe. So, the idea of a current companion star better fits the current evidence. The crucial thing is, even if this companion exists, it won't stop Betelgeuse from its ultimate demise, but it might influence the journey itself. Interactions with a companion star could affect how Betelgeuse ejects material before its final explosion, forms dust clouds, and how its structure changes. Understanding this interaction is crucial, not just for Betelgeuse, but for all massive stars nearing their end. What we learn here can help us better detect, model, and even predict supernova events across the Milky Way. If Betelgeuse truly has a hidden partner, it would profoundly impact our understanding of massive stars and their life cycles. First, it would provide a living example of how red supergiants interact with smaller companions. We know binary interactions affect many violent cosmic events, like Type Ia supernovae and neutron star mergers. But Betelgeuse offers a new case, a massive, bloated star showing subtle signs of companion star influence before its demise. Secondly, this could change our understanding of stellar mass loss. Betelgeuse is surrounded by complex dust and gas clouds, likely ejected from its outer layers. A close companion could be helping shape or even trigger these ejections, disturbing its outer atmosphere. This could cause the dramatic dimming events we observe. What seemed like the star itself, burping out dust, might actually be a small companion star, gently nudging it with gravity. Thirdly, this discovery could allow us to more accurately predict when a supernova is ready. By studying how a companion affects the primary's mass, rotation, and outer structure, we can better estimate when stars like Betelgeuse are nearing explosion. Though it may still be tens of thousands of years away, Betelgeuse is a key lab for studying pre-supernova behavior. So what's next? Future observatories, like the James Webb Space Telescope and upcoming X-ray and UV astronomy missions, might offer enough resolution and spectral sensitivity to directly detect that elusive companion. Infrared instruments might penetrate the dust, while UV and X-ray tools could reveal energy signals from the orbiting body itself. Meanwhile, Earth-based telescopes will continue tracking Betelgeuse's brightness curve, motion, and spectral features. If that 2,100-day cycle continues as expected, astronomers will have more chances to test predictions about the companion's position and influence. What makes this research so exciting is that the star we're studying is one of the easiest stars to see with the naked eye. We're not observing some obscure object in a distant galaxy, but a familiar neighbor. It might be hiding secrets we're just beginning to understand. As our instruments become more advanced and our models more refined, we may soon clearly see Betelgeuse's silent companion. Whether it's found to be a small star, a substellar object, or something entirely unexpected, it will change how we view supermassive stars, evolution, and demise. One thing is certain: Betelgeuse's final act might be more complex